Okay, guys, so we had a little bit of an issue when we turned the subs on. The passenger sub was working fine, driver sub was not. Okay, guys, I just want to go over quickly how to match up an amplifier and a subwoofer set. Also, just quickly, apparently I live in Balzac. I live in Balzac. Anyway, so we're going to start with an example of choosing the subwoofer that you want to use and then matching it up to an amplifier. So right now I have Alpine Type R's pulled up. This is my favorite subwoofer personally. So we're just going to click on this 12-inch. So it is a 12-inch subwoofer with a dual 4-ohm voice coil, which means that we can either run this in a 2-ohm configuration or an 8-ohm configuration. Now, if we're only going to be running one, we're going to be running it in a 2-ohm configuration. The other thing that we want to look up is specifications. So right here, our power handling is 300 to 750 watts RMS. What this means is that we do not want to go under 300 watts, and we do not want to go above 750 watts continuous power. So we would add that to our cart. We're not going to buy the that. And then we are going to go look for an amplifier. Now, this is where it gets goofy. This is a bridgeable amplifier. What this means is that you can run two separate channels off of this. If you look though, it does not actually show me the outputs on it, which is really annoying. So I would not buy this one. I typically stay away from Boss because it is a Chinese brand that is not very good. A lot of people have heard of Boss, but here's the thing. This claims to be a 1600 watt amplifier. Well, let's go and check if that is true. Really easy way to check. Has 230 amp fuses. What does that mean? The most current that can go through this amplifier is 60 amps. At 12 volts, we're going to take away 2 volts for efficiency purposes and assume this 10 volts, which means that this is a 600 watt amplifier. Might go up to 700 watts at 14.4 volts, but this is not a 1600 watt amplifier. It is a 600 watts amplifier. And that is how you tell what an amplifier is actually rated at. Now, another good thing that I can show you here, though, is that there's only one speaker output. And if you see, it says monoblock. This means that this is only a single output amplifier. This is a very good choice for a subwoofer amplifier as long as you understand that this is only a 600 watt amplifier. Another thing to look at is the fact that it is 2 and 4 ohm stable, meaning that if you were to try to run 2 of these subwoofers on here at 1 ohms, this would go into overcurrent protection. So you can only run this at 600 watts at 2 ohms. Now, is this a good choice for our subwoofer? Absolutely. Would I pay $173 for a 600 watt amplifier? Sure. Well, let's find a good brand name. Alpine. Typically, they don't have a bunch of BS. Nominal voltage, it highlights here, 14.4. It always, this also breaks down your maximum wattage per ohm. So, there's only 2 and 4 ohm stable. You can get 500 watts at 2 ohms. We're running 2 ohm subwoofers. But you can only get 300 watts if you are running a 4 ohm subwoofer. So that is very important to keep in mind. And if we look at it, this actually has 230 amp fuses. So looking at that, you might be able to stretch this out into the 60 amp range, the 600 watt range, but it's probably going to be going into overcurrent protection at that time. Also, fuses are always input fuses. They are never output fuses. Keep that in mind. Oh, good brand name. As we can see, $230 versus $175 on the Boss. Are they going to sound the same? Most likely. Now, the brand that I really like is Hyphonics. You can only buy their Zeus level amplifiers on Amazon. And Zeus have the same issue that Boss has. So this claims to be a 1,000-watt amplifier. Well, let's check if it's actually 1,000 watts. Oh, look at that. It's a 700-watt amplifier, not 1,000. So just something to keep in mind. And again, with 14.4 volts nominal, you might be able to stretch up into the 1,000-watt. But good luck with that. Oh, actually, they do have a Brutus, but this is a 4-channel. We're working with subwoofers right now. Do not buy a 4-channel for subwoofers. Go with 2 or 1. If it's a 2-channel that you're buying, you're going to want to look for this. It says bridgeable. Now, I'm just using this as an example. This is a full range amplifier, and you can use a full range amplifier for a subwoofer if you have high pass and low pass frequency cutoffs in your head unit. I do not. And typically, if they don't have high pass and low pass adjustments on the amplifier, they're usually cheaper amplifiers. Anyways, if we are bridging this amplifier, what that means is we're going to take the right positive and loop it into the left negative. And then you're going to use the positive on the left and the negative on the right to go out to your subwoofer. Now, you're going to need to look at your owner's manual for your individual amplifier because some of them are internally bridged. And if they are internally bridged, then you don't need to have this little jumper in between. But that would be how you bridge an amplifier. And again, it needs to specify that it is bridgeable. Do not try to bridge an unbridgeable amplifier because that means that you're looping more power into this output and you could end up blowing one of your outputs. Could end up blowing both of your outputs. Could blow up the entire amplifier. So just don't do that. When looking for an installation kit, this 4-gauge wiring kit is going to do the same thing that this 4-gauge wiring kit is going to do, which is going to do the same thing as this 1,500 watt. No, never mind. Ignore that. What is this? What is this garbage? Is that 4 gauge? 10 gauge red. This is not do not run 1,500 watts off of 10 gauges. Do not run 1,500 watts off of a 10 gauge wire. This is why we do not go off of wattage ratings on installation kits. We go off of the gauge. 4 gauge is good up to 75 amps, which is about 750 to 1,000 watts. 6 gauge is good up to 60 amps, which is good for 600 watts. Stretch it up to 720. 8 gauge is only good for like 400. So keep that in mind. I always run 4 gauge because it's just better not to overheat the thing. But really, the difference between a $30 and a $61 kit is usually just these stupid attachments that come with it. When I measure resistance across this terminal, it's open. So, and if you look, it's kind of melted in there. It's hard to see. So anyway, the thing that I said about these DS18 boxes that they were okay, ignore that. They are crap. So now I'm going to run over real quickly how to tune your subs, because if you just hook your subs up and pretend everything's going to be all right, it's not. You're going to blow your subwoofers up. Now, I tuned these already, and I am getting a little bit of buzzing out of this subwoofer, but I can feel air coming out of it, which tells me that it is not sealed properly. So I'm going to have to seal this box up better. And once that's sealed, if it's still buzzing, then I have to put a crossover, basically a tube connecting these two boxes, because if the interior of this box is not big enough, it's supposed to be 0.75 feet. This should be big enough, but I took the outside measurements. It was a little bit over. I don't know what the inside measurements are. This might not be big enough. I did pack it with foam, which helps, but still might not be big enough. So once I silicone this, if it's still buzzing, I'll put a crossover in. And that just shares the airspace between the two boxes. It allows for larger airspace for this box. So once you have everything set up, you're going to go into your head unit and you're going to set up your low pass filter so that your car speakers do not play frequencies below 500 watts. So that your car speakers, the ones in your doors, don't play frequencies below 500 hertz. The reason for this is you don't want to end up blowing one of your door speakers. Once you do that, hop on YouTube, go through, and find what frequency your subwoofers react to the best. If you just Google frequency test, it comes up. It goes through a range of like 0 to 20,000. You're not going to hear anything over 500, but you want to figure out where it's loudest. Now, the other way you can do this, and the way you should do this, but it is kind of obvious by ear, take a voltmeter, set it to AC, connect it into your speaker output, and you're just going to watch for when it shows the highest voltage. And that's going to be your highest decibel response, your best decibel response, which basically that is the frequency that your subwoofer is going to be loudest at. So once you have that information, go and look up a sound that's just a continuous sound of that frequency. So for these subwoofers, it was 80 hertz. They really liked 80 hertz, so I tuned it at 80 hertz. Once I had it at 80 hertz and I had it playing a continuous sound, I connected back up to my speakers with my voltmeter. I turned my volume on my radio up to 75%. I started low and I turned my gain up until I hit the proper voltage for the wattage. Okay, guys, I've trimmed my beard, so my mic is a little harder to stick in here. Say Levy. Anyway, I just want to go over these calculations quickly, because if you want to actually calculate this, you're going to need these equations. You're never going to remember it. You can just pull it off of here, or I can explain to you how to get it. This might be over your head, so skip it if you don't want to learn it. If you want to learn it, that's great. So we have two equations. We have power is equal to current times voltage. So power in watts is equal to current in amps times voltage in volts. And we have voltage is equal to current in amps and multiplied by resistance. Okay? So the issue with this is that we know resistance, we know power, but we don't know voltage and we don't know current. Most amp meters do not go up high enough in current values to measure current. Well, these two equations allow us to calculate what voltage we need based on the power and the resistance. So I'm just going to manipulate these quickly so that you guys can see. Now, the first equation that we're going to manipulate is power is equal to current divided by voltage, or multiplied by voltage. We're going to divide both sides by voltage. On this side, the voltage just cancels out. And on this side, we now have power divided by voltage is equal to current. So what that means is current is equal to power divided by voltage. Now, there's two unknowns in this equation. There's two unknowns in this equation. However, we have another variable in here that we can now manipulate. So what we're going to do is we're going to replace I with what we just calculated or figured out. So I is now going to be replaced with P divided by V. Okay. So we are now left with V is equal to PR divided by V. So voltage is equal to power in watts multiplied by resistance divided by voltage. Now what we need to do is we need to find out what V equals. So we need to get V off of this side. So we are going to manipulate this equation. So in order to get rid of the V on this side, we multiplied the top by V, which then cancels V out, and we're left with VV on the other side. Well, VV is also V squared. Okay, so V squared is equal to PR, power multiplied by resistance. In order to get rid of V squared, we're going to take the square root of it, which means that voltage is equal to the square root of power multiplied by resistance. So our final equation is voltage is equal to the square root of P multiplied by R, or voltage is equal to the square root of power multiplied by resistance. We now know that P is equal to IV, or power is equal to current multiplied by voltage. Voltage is equal to current times resistance, and voltage is equal to the square root of power multiplied by resistance. We don't know what the voltage is. We know that in this scenario, the resistance is 1 ohm, and we know that in this scenario, we are shooting for 400 watts. So let's calculate this quickly. So V is equal to the square root of PR. We know that power in wattage that we are aiming for is 400 watts. We know that the resistance that we are running is 1 ohms, which means that the square root of 400 times 1, which is just the square root of 400, is 20 volts, which means that the voltage that we are aiming for is 20 volts. Running 20 volts in a 1 ohm subwoofer system is going to give you 400 watts. Now, just to verify this quickly, we're going to calculate current. So we already know P equals IV, V equals IR. Voltage we have, power we have, resistance we have. We do not have current. Some people find it easier to look at it this way. The power triangle. You see, voltage is equal to current multiplied by resistance. If you want to find any item in this triangle, so let's say we want to look at voltage, remove it from the triangle and we have current beside resistance, and anything beside each other is multiplied. If we want to find current, then we take it out of the triangle and we have voltage over resistance, which means that anything that is over is divided. So we're going to have voltage divided by resistance. Now, this is super easy. Voltage is equal to 20 volts. Resistance is equal to 1 ohm, which means that current is equal to 20 divided by 1, which is 20. So we're going to have 20 amps in this system. Okay, so now that we know that 20 is the current, power is equal to current multiplied by voltage. 400 is equal to 20 multiplied by 20. That checks out. We know we're shooting for 20 volts. And that's how you figure it out. Now there's a calculator online for how to do this. I just know the two equations that you need to manipulate in order to get the proper equation to calculate it. Are watts. I set these to 400 because you should set them to 80% for the first month that you're running them. The max I'm going to be running them at is 500 watts, so I will turn it up afterwards if I decide I want to. I might just leave them at 400 watts because they are pretty loud. The decibel response on these subwoofers is phenomenal. It's very similar to an Alpine Type R, which basically what that means is you get a lot of volume out of a little bit of wattage. And that's also just because they're high efficiency subwoofers. They're both 2 ohms, they're dual voice coil. So essentially, it's like having 4 subwoofers, but they're working together, and you're getting more current for less voltage. So in your equation, you're getting more current from your wattage. And current is going to affect how loud your speakers are. So, well, for mine, I have single ohm because these are run in parallel. Both of them are 2 ohm. They have 4 ohm voice coils, but there are 2 of them. I ran them in parallel in each, which gives me 2 ohm per subwoofer, and then they're run in parallel again. So they're 1 ohm. And 400 watts to a 1 ohm subwoofer is 20 volts. So we want to run 20 volts to it, and that's what I tuned it to. Starting low and turning it up until it got to 20 volts. And actually, I think I set it to like 18-ish because the buzzing is pretty bad from the subwoofer at that point. So I might turn it up later once I have it sealed, but I might just leave it at this point because honestly, they sound really good. Because I showed installing this head unit, I'm going to go over the settings in here. Depending on the head unit that you have, your settings are going to differ. So, the only real place that you have to set things up is this audio settings. Now you see I can bump up the volume per frequency, but I can't adjust any crossovers here. Go into sound field, all I can do is turn bass on and off, and that does turn your subwoofer on and off. That's it. So what we're going to want to do, also I'm in Canada, so I have it set to, I'm a right-hand driver side. We're going to turn bass on. We're going to turn loudness on. You need this loudness on for when you're setting your subwoofers. No, you need the loudness on when you're setting your subwoofers because you want to be measuring the maximum volume that you're going to be pulling from these subwoofers at any given time. RMS is the maximum wattage that you want to continuously pull. It is okay if it spikes every here and there, but you're going to be causing extra wear on your subwoofers. You're going to cause failure earlier. That is why I set this up this way. Now I can turn loudness off, and that can be my base for my subwoofers. And then when I want more subwoofers, I turn it back on. There's a bunch of different options. Either way, as you see, there's no crossover options in here. However, this is a Android head unit. So I downloaded Crossovers. Crossovers is a free app in the Play Store. It is either Russian or Ukrainian, so take that with a grain of salt. But you have your low pass and your high pass filter. The only one that I really played with was the low pass. Because the high pass you can set on your subwoofer. And essentially what you want to do is set, so my subwoofer's maximum frequency is 250. That's the max that my amp will go up to. So I'm going to set my filter cutoff at 250. Now what this does is this is going to set it so that my car speakers do not play a frequency below 250 watts. 250 hertz, not watts. Now in this video, I kind of garbled this up. So let me explain something. When you are setting your low pass filter, that is only the frequencies under that filter is going to play through that speaker. You set your low pass for your subwoofer. Your subwoofer, essentially the way that you want to set this up, using the low pass filter on your amplifier, go to maximum, play a song, you're going to hear some distortion, turn the low pass frequency down until the distortion goes away. Once that's done, don't touch it anymore. Then go on YouTube, find a frequency spectrum sound, and you're just going to put your hand on your subwoofer so you can feel when it stops vibrating, And you're going to, it should start at, 0 all the way up to 20,000 hertz. So starting from 0, you're going to feel it vibrate until it hits a point. With mine, I believe it was 125 hertz area. That's where you want to set your high pass filter. That means that anything that is over 125 hertz will be played by the rest of your sound system. If you end up leaving it unmatched, you're going to have sounds that don't come through. And that's it. The rest of it I didn't touch. Don't need it. From there, you then play your 80 hertz sound and adjust your gain accordingly. One last thing. While I was setting this up, I did set up a battery charger just to ensure that my battery didn't die while I was doing this. Another thing to note, your alternator will charge your battery at 14.4 volts. If you set up your amp at 12 volts from your battery, you're going to be spiking higher than that maximum that you set up, which means that you can still blow your subwoofers. Hence why I was okay with setting mine a little bit lower. I set it at 18 volts instead of 20. Ideally, the best way to set this up is when your truck is running or your vehicle is running. Different alternators charge at different voltages, so it's not a one-size-fits-all situation here. So I would measure your voltage while running, measure your voltage while not running, or just set it up while running. That's going to wrap it up for the subwoofer segment, guys. Wait, stop. We're not quite done. I just want to cover on something quickly. Parallel versus series voice coils. When you have a subwoofer with dual voice coils, you will see that you have 2 sets of terminals inside of the subwoofer. Just how you want to run these. If you only connect one of them, you're only going to be running through one. You're going to get half the volume out of it, the performance out of it, whatever you want to call it. In order to run 4 series, take this positive terminal, connect it to this negative terminal, and then take this positive terminal, run it to your amplifier, take this negative terminal, run it to your amplifier. That will run in series. What series does is it's going to double your resistance. So if you have a 4 ohm voice coil like this one, so this has 2 4 ohm voice coils, you're going to be running an 8 ohm subwoofer. If it has 2 2 ohm voice coils, you're going to be running a 4 ohm subwoofer. So if you have dual 2 ohm voice coils and you don't have a 1 ohm stable amplifier, you need to run these in series. Now, if you are running in parallel, you need to take this terminal and you need to connect it to the other positive terminal, and then you need to take the negative terminal and connect it to the other negative terminal. Then you can connect either one of the negative terminals and either one of the positive terminals to your amplifier, and that will be running in parallel. Now, when you're running in parallel, rather than doubling, you are now halving the amount of resistance that your circuit is seeing. So in this case, where we have dual 4 ohm voice coils, you're going to be seeing 2 ohms to the amplifier. If you had a dual 2 ohm voice coil, then you're going to be seeing 1 ohm to the amplifier. So just keep that in mind. And 2, I've been working on them for 14 years. I just know them very well. Plus, the last time that I built an LS motor, it blew up, and every LS motor that I see built on YouTube blows up, and I don't have the budget for that. But anyway, if you like the content, subscribe, leave a comment, hit the like button, hit the notification button if you do subscribe. I post a short every day. I go live every day for about an hour playing video games. But if you have questions about car stuff, you can jump on that live and you can ask me questions, and I have no problem answering them. The video game stuff is just content. It's just to bring attention to the actual live stream. You are free to ask me whatever you want on the live stream. Whether I'm going to answer it or not, that's a different question. But there is that. Now, the other thing is too, I usually live stream Warzone. I'm not the quickest to grab the comments in my comment section. So if you comment and I don't catch it right away, give me about a minute or two. If I still don't comment, just ask it again. Yeah, I'm not trying to ignore you. I just didn't notice it because I was in a firefight or something like that. Alrighty, guys. I love y'all. Y'all beautiful. Hope you had a great day. Okay, bye.